Okay, so where are we just now? Okay, so this is how, if let's say you want to differentiate the y with respects to x1, you can also differentiate whatever variables, but we just want to show you how the coefficients in the polynomial functional form look like. Okay, so I will move to the next slide. Okay, as I mentioned to you, when you have x squared, you're gonna have this kind of shape. You can have U shape or inverted U shape. Okay, so how do the conditions of U shape look like? So normally in this case, so you can see the shape, if you can see my cursor is going down. So this is the case when your beta 1 is actually less than 0. So it's actually falling. And then when your beta 2, remember you're going to have two coefficient, beta 1 and beta 2. So when your beta 2 is positive, then your shape will increase. That's why you have this kind of U shape. Well, how about inverted U shape? Okay, so in this case, you can see that your beta 1 is actually positive. So you have an increasing pattern, but then your beta 2 is decreasing or less than 0. So you have a decreasing pattern or trend. So you have an inverted U shape. Okay, so here is my question. Basically, I cannot think of one example given the evening time. How do the U shape look like in the equation? Okay, I cannot find the examples, the case of U shape. But if let's say you are talking about this inverted U shape, so normally when have you learned about environmental Kuznets curve? Anyone? Have you heard about Kuznets curve? Or you haven't heard about this term, which is less likely?
Haven't heard, madam. First time you say just now. I heard.
Okay. Well, I don't know. Maybe it is covered in the fourth year course. So when you talk about environmental Kuznets curve or Kuznets curve, you're going to have this inverted shape. So normally your y-axis refers to your income, while your x-axis refers to your uh, pollution produced. So it says that in the beginnings of the stage, you are in the you are in the agricultural sector. So your income is actually very low. Remember, y is your income. So x is actually your pollution produced. So your income in the industrial sector is very low, but your pollution is also, I think it's better for me to draw here rather than talking. So this is actually your income. This is actually your pollution. Okay. Is it this way? Or is it the opposite? Let me see. Increase. Oh no, the opposite. Okay. It's good to draw it so that everyone can see it. This is your pollution. This is your income. Okay, because normally I put income as y, so I cannot let me write income properly. Income. So you're gonna have this kind of inverted U shape. So it says that this is what you call Kuznets curve. Okay, so it says that at this stage, this is what we call agricultural stage. And then you're going to have, this is industrial stage. And then you're going to have, this one is service stage. Okay, at the industrial stage, of course, the income is actually very low, right? You can see that this is the income. It is very small. And then pollution produced is also very small at this stage. But then when you move to the industrial stage, what happened? You have many factories, you are producing more output. At the same time, you are also producing more pollution. So what happened is that your pollution here is increasing because the more you produce the output, the more you get the profit, the more pollution you have. And at this stage, you can see that your income is actually relatively higher compared to the agricultural sector, right? of course, those who are working in agricultural sector, their earning is actually lower, relatively lower compared to those who are working in industry. Okay, but then after the turning point, this is what you call a turning point, then your pollution, you can see that your pollution will actually reduce, but then your income is even more. So this is what we call a service sector. Okay, so when people are moving from industrial sector, this is especially true for developed countries. Previously, they are producing all these tires, machinery, and so on. But after certain time, they are becoming more developed, so they cannot tolerate all this pollution. So what happened is that they simply establish their factory in poor countries. So they are developing, they have higher purchasing power, but because they cannot tolerate pollution, so they located their factory in a different country, in a poor country, and then they are moving to a service sector. So they are offering service, medical service, all this kind of service. So what happened is that their country become cleaner. Okay, so when they move to the service sector, because they are just offering service to people, they can charge more. Okay, can you imagine? Sometimes you go to clinic, the doctor, because they are offering service, you don't know how much for different kind of illness. So they are charging you depending on their their profession. So when you are in the service sector, of course, your economy is greener or cleaner, and then you also have higher income. So this is the case if, let's say, you have what we call inverted U-shaped curve. Okay, this is when you talk about the relationship between income or and pollution, you have this kind of inverted U-shape. Well, can someone give me the relationship between your independent and dependent in the case of U-shape? Anyone can think of any relationship, any economic relationship? Did you understand how come you have this inverted U shape? Is it clear?
Clear.
Okay, how about U shape? Because I was thinking the example when I look at this, okay, what kind of example in economics theory, in economic concept? I was like, anyone has a better example before I come out with something not really relevant? Anyone?
How about
Honest?
rule of diminishing marginal return?
Okay, diminishing marginal return. So if you have diminishing marginal return, you will only have falling shape. You cannot have an increasing shape. So this is U shape. So diminishing will be, let me draw a different, well, it's a good try. So if you're talking about diminishing marginal return, you can have something like this, right? So it will keep diminishing, but you don't have this kind of shape to make it U. Diminishing will keep diminishing. That's it. Until the point that you may reach to zero. This is diminishing marginal return. How about what can explain about this increasing shape? Anyone? Anyone want to try? Can you think of any theory in any economic relationship that have this kind of shape? Cost curve, madam. Cost curve. Well, that's right. Well, that's good. Okay, okay. That's good. Can you explain? Idham? It is correct. Can you explain?
Um, I'm not really sure, madam, because I'm just taking a guess.
Okay, so let me explain. So let me just write it here. Okay, where should I put? This is the output because economic of scale. Okay, let me explain this first. This is the cost. Okay, okay. Right? So remember when we talk about economics, we want to see the relationship between the theory. We want to see the relationship between the variable. Okay. So if you are producing something, just assume that you are a factory manager. You are the owner of the factory. Manager is not the owner. You are the owner. Okay. So when you are producing something, of course, you're gonna start with the fixed cost and variable cost. So you remember the fixed cost, the startup cost is very huge, right? What is the fixed cost? Fixed cost consists of the machinery, the factory itself, and maybe you have to purchase the land. That is the fixed cost. Can you imagine how large the fixed cost is? So perhaps, um, well, perhaps this is your fixed cost. Let me write here. This is your fixed cost. It is huge. But then when you start operating, what happened is that you start operating, this is the your output when it is 0. So you incur only fixed cost. But then later on you produce 1 output, you produce 2 output until 100 output. So or maybe until 1000 or whatever output. So the moment you keep producing the output, you keep producing the products, what happened? Your cost will keep falling and falling and falling, right? I mean that the more you produce the output, the lower the cost of your fixed cost plus the variable cost. But after sometimes, after many years, a few years, maybe your machine will start to depreciate. Some of the machine start facing all these kind of technical issues and so on. Remember, machines has his lifespan. The same thing with your car. So the moment that you purchase the car, it is in a good condition. But after 5 years, what happened to your car? It started to show its true color. It started to um, throw tantrum on you. So you have to incur so many costs. So at that point of time, when you have this kind of turning point, you start your cost is not diminishing, lowering. You start incur higher costs because if you want to repair an old machine, the cost is even higher. So that's why people said that when you are dealing with machine, it's better to purchase a new one because if you want to repair the old machine, the cost is even lower if you purchase the better one, the new one. So at this point, the more you repair your machine, the higher the cost will be. Is it clear to everyone? Is it make
Clear,
sense to you?
madam.
Does it make sense to you?
Yeah,
Yes.
makes sense, madam.
Yes. Okay, that's good. Well, I was thinking I should give because I have another example which is a bit difficult. I mean, I can explain, but
Madam,
yeah, yeah. What is it? You want to ask question? Uh-huh.
madam, I'm
Can
not
I what?
clear.
Can I what?
Explain again.
Okay. Well, should I? Okay. Okay. So I just want to show you how good you have this kind of U-shaped curve. Okay, if you can see my cursor, because in economics we have when we want to draw a diagram, you may have different shape of diagram. So I have explained how the inverted U shape occur, and now this is the example that is given by your friend how the U shape curve may occur, may have some relationship in your between the variable. So the example is the cost. Okay, so remember, if let's say you are the owner of a factory or the owner of a products, you will incur the fixed cost. Okay, um, I don't know. Should I draw a new one or this is fine? So you will incur a fixed cost uh, at the started point. So the fixed cost normally very huge. What is the fixed cost? You will incur, for example, you have a factory. You have to purchase the factory. Of course, the cost is large. You have to maybe purchase the land or rent the land. Land is also expensive. What is the examples of fixed cost? Land, factory, or the machinery. You also have to purchase the machinery. So all these fixed costs will give you a huge cost. So that's why I put it here. So the startup cost is very large because um you are um okay, you are involving with the fixed cost. Okay, but remember, um at the beginning you have the fixed cost, but later on you will also have the variable cost. So how can you have this U shape? So you can see that you start with the large cost. This is the output, or what we call your product at the beginning of the period. So you have zero product, but later on you start hiring the labor or worker. So you produce one output, you produce 100 output, you may produce up to 500 output. Output means you may produce 500 products, whatever products. So when you producing the products, so your cost, basically in total your cost is fixed cost plus variable cost. But when you when you start making profit, okay, so your cost will be decreasing. It will keep decreasing because of the profit. You sell your item, of course, with the margin, so you will get the profit. So the profit will compensate for your fixed cost. So your total cost will be reducing because of the profit. But at certain point, so maybe this is after 10 years of time, after 15 years of time, so your cost now will keep increasing. So how could this happen? Because at this stage, perhaps, we never know, perhaps your mission has started uh, showing its true color. It started, maybe your mission is not happy with you. You operated for a long time, so it's not working properly. It's not functioning well. So when you talk about machinery, so the cost of repairing an old machines is actually expensive. So you started incurring your variable cost, like repairing your machines and so on. Once you do that, so now your cost will be increasing. Okay, so the more you repair your old machine, the higher the cost. So that's why I said it's better to just replace a new one. But if you want to replace a new one, again, you have to incur the new cost. So regardless whether you are repairing the old machine or you are purchasing a new one, this is the time that you are increasing more of your costs. Is it clear? Is it clear? How does you have this U shape?
Yes.
Clear, madam.
Okay, let's proceed. Okay, so okay. So oh yeah, this is actually the examples of polynomial form. Okay, so what is it? You want to model annual employees earning as a functions of age of the employees and other measures. Other measures means and other variables. Okay, so what is expected impacts of age on earning? So this is your earning, your dependent variable, and you want to see the impacts of age on your earning. So I purposely didn't want to give you this example because I'm trying to give you more examples so that you can have more exposure. Okay, so what is your expectation about age? Do you think that age gonna have this U shape or inverted U shape on the earning? What do you think?
Inverted U, madam.
Inverted U. Why? Can you explain?
Uh, because as we are as we age, as we get older, meaning that we are climbing up our career, so it gets our earnings started to increase and increase and increase, madam.
Everyone understood that?
But at the
Is it
decline point, I don't know.
okay? So, well, let me see whether your age and earning, or I put income, right? So, income and earning are the same thing, right? Okay. So, well, um, so Idham said that age and income has an inverted U-shaped curve. Let's see. How does we want to explain if it is inverted? Is it really inverted? So, so we're going to start with 0. Okay, so this is 0 age and 0 earning, of course, right? If you are not born yet, how could you get any earning? Okay, so you keep increasing your age. For example, this is the age of 20. And what happened to your earning? At the age of 20, is your earning higher? No, maybe at the age of 20, your earning is 1K, 1,000. And then the more you age, I mean, the older you are. So this is, so when I move to the right, because this is the variable is actually age, right? So this is age, so it moved to the right. So income, it will, or earning, it move up. So the more you are aging, I mean, the older you are, so you can see that how about the income? Income is increasing. Is it true? Of course, at the age of 20 years old, maybe you don't have experience. You don't know anything. Your knowledge is very limited. For example, if I change 20, because at 20 you haven't graduated yet, I can change it to 24 once you graduated. But as a fresh graduate, do you think that people will pay you more? No, because they're assuming that you are the newbie. I mean, you don't have experience. So normally your income will be, your earning will be lower. But the more you, the older you are, the longer you are in the company. So what happened to your income? You will have, I mean, increment every year, right? Because every year they are assuming that given the experience, given the years has passed, of course you will get some knowledge, more experience. So your earnings are higher. Okay, but then this is the turning point. Remember, this is the turning point. So the turning point here for the age, maybe 65 years old. So do you think that at the age of 65 years old, this is the retirement age. So when we have this retirement age, we are assuming that if let's say you still continue working, your earning will fall. Okay, why is that? Because at this age, the older you get, basically your productivity will fall. You cannot be as efficient as when you were in the age of 30 or 40. So we are assuming that your productivity will fall. So the same thing with your earning. So people will not willing to pay higher income for the older people. So this is true. Just to let you know, this is true when you are talking about the normal labor, when they are actually using their their physical capacity. Okay, because we are assuming that if let's say they are working hard using all their four legs, I mean working. So basically, the older they get, they don't have the capability of conducting their work. But this is not applicable for the professional job. For example, you are a medical doctor, you are a professor. The older you are, the more experienced you are. So the higher your income, the earning. But this is true in the case of those who are working, those what we call the low skill labor. Okay, so we have high skill labor, low skill labor. This is true for the low skill labor because they are using their physical body. Okay, so if they are getting older, their body is getting weaker, so their earning will be lower. Is it clear?
Yes,
Yes.
madam.
Yes. Clear.
Okay.
So, madam, sorry,
Uh,
madam. So, for the case of high skill labor, meaning to say it cannot be inverted you lah for the high skill. If you are talking about the high skill,
yeah,
it will
cannot.
keep on increase and increase and increase.
Yes, it will be increased at the increasing rate.
Okay.
The same thing
Okay.
with the CEO. Remember CEO, they are older people. But then how about their income? Their earning. Their earning is 90% of the whole company because they are more experienced, they are high skill level. So even though they are retired, well, just give you a good example. For example, our rector, he has retired, but he earned the most in the university. Why? Because he is the highly skilled labor. I mean, not labor, highly skilled worker. Okay? So in that case, it is not applicable. Okay? Is it clear?
Yes. Okay. Clear, madam.
Okay. So in that case, because they start increasing at certain age time, they start falling. So well, you believe that when we talk about age, you're gonna have a quadratic form. Okay, so we call it quadratic. Okay, so so you're gonna have age as a linear form because you don't know whether remember you can have an increasing and then you can fall as well for the age squared. Okay, so you have to have two variables that measure the age. Okay, because sometimes you couldn't even found significant relationship for the inverted U shape. Sometimes it's just linear because it's not even up to the turning point. Okay, so that's why you're gonna have a linear. I mean, just the normal age in a linear form because in order for you to get this quadratic form, they have to pass the turning point. That's why you have to because if you have only the squared, the quadratic form, if it is not up to this turning point, this variable will not be significant. Okay, so you have these two variable for measuring the age. Okay, so this is the best way to choose a functional form. Of course, you always have to refer to the theory. If theory said that you have to have U shape, so just follow the theory. If let's say the theory said that you have to have a log function, just follow the theory. Okay, because normally, even though our finding doesn't support the theory, it's just because our data might be small in number, might be our data is not sufficient enough, or maybe our equation are not free from errors. Remember, sometimes you may violate the assumption and so on. So just follow the theory, okay, with regard to the functional form. Okay, so you can see kind of this is like a box. Okay, this is how you want to explain all different functional form. At the moment, we have learned how to interpret the linear form, lin form, right? In the previous chapters, when I look at the definition, they explain the changes in y given the change in x. But normally in econometric, if we want to explain, if you want to interpret the variable, we have to interpret if, let's say, x change by certain number, it will affect y will change by certain number. So we will start with the driving factor. When the driving factor change, what happened to y? Okay, but previously I discovered that y changed by this amount because the x changed by whatever. It can be done by that way, but normally we will start with the driving factor, which affect whatever the dependent variable. So you can see this is kind of the summary of interpretations for different types of functional form. You have linear function, you have uh, log, you have semilog. Semilog can be log lin or lin log, and then the polynomial. So let's see how do they interpret. Okay, for the linear functional form, if x increased by 1 unit, what happened to y? Y will change by beta 1. So this is known for everyone. I think you have mastered this, right? You have seen this in 2 quizzes, I believe. Okay, second, this is log functional form. So remember, your dependent is log, your independent is also log. So when we have log in both sides, basically we are talking about elasticity. Elasticity are in the form of percentage. So how you want to interpret? If x increased by 1%, always by 1 unit, but because it is log, so it's a percent. Y will change by beta 1%. So if let's say your beta 1 is 2.5, so you can say that y will change, or in this case it's positive, y will increase by 2.5%. Just put the percentage because this is log. Okay, so in this case, because they have both log, so it's elasticity, okay, of y with respect to x. Okay, so now we have semi-log function. So in this case, your dependent is not ln, but your independent is log or ln. So what happened? Remember, this is log in your independent. So basically percent. So if you can see, if x increased by 1%, because the log is under the x. So if x increased by 1%, y is not percent, y is not log, it's just a unit. Y will change by, this is your beta, divided with 100 unit, because previously x is log, so you have to divide by 100 unit. Okay, so this is how you want to explain. So if let's say your beta 1 here is 10, so 10 divided by 100, so you will get, what will you get? Oh, I want to put here. So where is my, okay, I want to write. So if let's say your beta 1 equals to 10, so remember, you want to interpret, you have to divide your beta 1 with 100. So you divide with 100. What happened? So 1
0.
over 10. So 0.
0.1. 0.1.
So you will say that if x increased by 1%, y will, maybe in this case plus, right? Y will increase by 0.1 unit. Don't put 0.1%. So you just have to know how the functional form affect the interpretation. Now we have log in the dependent and unit linear in the independent. So the x is not log, x is just a unit. So if x increased by 1 unit, okay, so y, because it has a log, will change by, you don't really have to worry, roughly by, so whatever the value, your beta, so you have to multiply with 100%. So you have to multiply with 100 and then you can say percent. So let me give you another example. Oh no. Pen. Mm-mm. Okay. Okay. Where are we just now? So what happened? Okay. So we are talking about semilog when your dependent is log y. Okay. So your beta in this case, beta 1 equals to, let's just assume the value of 10, the same thing. Okay. How do we want to interpret? If x increased by 1 unit, so this is your x. If you can see my cursor. Can you see my cursor? I cannot see my cursor. Can you see my cursor? Yes? Okay. So if, can you? Cannot. So
Yes, Manda, yes.
okay. So it says that if x increased by 1 unit because there is no log in the independent variable, y will change, or in this case plus, y will increase by, so now this is the value of your beta 1, 10. So y will change by, you have to multiply your beta 1 with 100. So what happened to your beta 1? You're going to have 1, 2, 3, 1000%. Is it clear? Is it clear? Yeah. Okay. So normally the example will not be 10. They will give you in terms of 0 point something something. But I just want to give you the same example so that you can see the differences. Okay. So the polynomial, this is our quadratic form. Well, polynomial cannot, it's not only about quadratic. It can be what we call I forgot the name. The into the power of 3, it can be into the power of 4. So as long as it is not into the power of 1, we call it polynomial. But in economics, there are so many theories that deal with the quadratic into the power of 2. So what happened if you want to interpret this quadratic form? If x increased by 1 unit, so remember our x here is this is x1, okay? So if x1, so you should actually put, yeah, x1. Okay, if x1 increase, whatever the variables of x1 increase by 1 unit, so your y, remember you have to differentiate it, will change by beta 1 plus, because you want to differentiate, so 2 beta 2 x1. So this is how you want to interpret the quadratic form. Basically, you are trying to differentiate the function. That's it. Okay. So this is the summary of interpretation given different kind of functional form. Okay. Okay. Now we are moving to the leg independent variable. So when we talk about leg independent variable, normally it is in the case of time series. Okay, so remember for your syllabus, we are only covering the cross-sectional data, but leg normally happen in the time series data. Okay, so let's see. Not all situations imply a simultaneous relationship between dependent and independent. Simultaneous means when x1 increase, y will change simultaneously at the same time. But in certain cases, when x increase, y will change later, maybe next year, in the following year. So this is what we call lagging impact, or what we call lag independent variable. The independent variable will actually somehow lagging. Okay, the impacts are a bit lagging. So in many cases, time elapses between the changes in an independent variable and the dependent variable. Okay, as I mentioned to you, when your independent variable change, the impact is a bit later. That's why you call it lag. The periods of time between the cause and effect is called as lag. Okay, so let's look at the example. Many econometric equations include one or more lag independent variable. So this is, you can see that, well, this is just the general form of lag variable. You have y. You can see that this is t. T refers to the time series. You are not talking about I, cross-sectional. So t equals to beta naught plus beta 1. So you have x1, t minus 1. So if let's say your t in the y is actually year 2023, so t minus 1 is 2022, is in the last year. If let's say t minus 2 in 2 years time, I mean in the previous 2 years. Okay, and then you have the other variables. Okay, so let's look at the example, the real example, the impacts of price on quantity of cotton supply. So this is the C, quantity of cotton supply in year T. Year T means normally when we are putting T, it refers to the current year. So now it's actually year 2024. Okay, so this is the quantity of cotton supply in 2024. So it depends on what are the variable, the price of the cotton in the previous year, in 2023. Can someone explain to me how come the price of cotton supply this year depending on the price of cotton in last year? Anyone? Is it possible? Don't you think that the price should, the consumptions of the quantity supply should follow the current cotton price? Can someone explain to me how come when you want to supply the cotton, it depends on the price of the last year? Anyone?
Is it because of the inflation, madam?
Okay. Inflation is another variable. Okay, inflation is another variable. Okay, so well, okay, let me explain this. Okay, so C is the quantity of cotton supply in this year, right? Okay, so if let's say the price of cotton last year is very cheap. Okay, the cotton is normally used to make fabric, your clothes, right? So if let's say the price of cotton last year is very cheap, what happened to your demand, your consumption this year? Because last year is very cheap, so it will have a positive impact on the quantity supply. Because when the price is cheap last year, people are demanding for it. So what happened to the supplier? Because the low price, people will demand for more. So your supplier, you will supply more. Can you see the relationship? It is last year, but then because people demand for more, you will supply for more. Is it clear? So you can see that the impacts of the price, which is lower last year, affect your supply of the cotton this year. Because you will assume that, okay, because the price is low, people are demanding for it. So as the supplier, as a producer, you should produce more because you are assuming that you are expecting that they will demanding for more. So you will supply more by looking at the previous year trend. Okay, is it clear?
Madam, is it about expectation for future from the last year? I mean,
Well, when you talk about last year, it's not about really future. It's very near future, right? This year and last year. But when you talk about time series, all the variables are related. What happened in the previous year, for example, GDP, it will also affect this year. So all the variables are related with each other. When you talk about a series of time, it's not about expectation. It's just that the impacts are actually lagging. Sometimes what happened in the last year is not that when you change the price, okay, so this is what you call not really elasticity, but when you reduce the price, people will not respond immediately. For example, people reduce the price of computer. You already have your computer, right? So you will not simply throw your old computer and purchase a new one. So the impacts of reduction in price will not be reflected immediately in terms of high demand. So people will take some time to respond to it. This is the case of what we call lag independent variable. People will respond a bit later. Okay? So it's not about expectation. It's just that the response is a bit late. It's a bit lagging. Okay? Is it clear? Yes, I will move. If you keep silent, I will keep moving. unless you want to stop me. Okay?
Yeah.
Okay. I will assume silence means you agree or understood. Okay. Okay, so just stop me if you have any concern, okay? So this is slope dummy variable. It's not about the slope of the dummy variable, okay? It's a this is the term. Okay, so let's have a look at the first point at intercept dummy. Okay, so you know the intercept, the beta knot for the dummy changes the constant or intercept term depending on whether qualitative conditions is met. Means that, remember last time in the previous chapter, whenever you have a dummy, it will actually change your normal intercept. So you have beta knot, right? So this is your intercept. Perhaps, okay. That is it. This is your intercept. Okay, this is perhaps beta naught. But then the moment that in your equation, y equals to beta naught, and then plus beta 1, perhaps this is dummy. So the moment that you have dummy as your independent variable, dummy will give you a different intercept. So dummy will have your beta naught intercept plus the intercept for the dummy, perhaps beta 1. So this is the intercept for your dummy. This is the dummy. Okay, whenever you have the dummy, it will have a different intercept. The intercept will be additional, extra. Okay, so where D, in this case, D is the ice observation made on a particular condition and zero otherwise. It doesn't matter. It just want to tell you that when you have a dummy, it will change your normal intercept, your current intercept. Okay, so interaction term means that the variable are interacted with each other. That's why you call it interaction term. The term are interact with each other. Okay, is an independent variable that is a multiples of two or more independent variable. Okay, so an interaction term has its own, of course, coefficient. It should has its own beta. Okay, so you can see that this is your x. So x gonna have its coefficient, which is beta 1. You have D, dummy. Dummy will have its coefficient, which is beta 2. Interaction term, as I mentioned to you, the interaction between 2 or 3 or more variables. So, for example, you believe that x and D are interacted with each other, so you will have another variable, another function. So you have this y equals to beta naught plus beta 1, this is the impacts of x on y, plus beta 2, this is the impacts of D on y, and then you believe that x, so this is another beta 3, you believe that x and D are interacted with each other, and these two joined together may have an impact on your y. So you have x multiplied with D, and this is what you call interaction term. This is just the examples of two variables. You can have 3 or more variables, and they form as an interaction term. They are called as interaction term because they are interacted with each other. Okay, so basically, well, we can expect that because you already have x here, you already have D here, but then you have x and D. So in this case, you may face a multi-core issues. You may or you may not. When combinations of these two variables have a different impact compared to their impacts individually. You may or you may not, but we are assuming that because this x and D are actually part of x and D here in beta 1 and beta 2, they may have a multi-core issue. Okay, so this is what we call interaction term. So interaction term can involve, well, can be in many forms. It can be like two quantitative variables x1 and x2, and then they form their coefficient, which is beta 3. It can be two dummy variable, d1, d2, or it can be both quantitative and dummy, x1 and d2. Doesn't matter. Interaction term can be any variable that has interacted with each other. Okay, so a quantitative variables and dummy variable. So number 3, when your x1 and d2 interacted with each other, you call it slope dummy. Okay, so I mentioned slope dummy is not that the slope for the dummy. It's actually interactive term when you have quantitative and dummy variable put together. They are interacted with each other. This is what you call dummy, stop dummy. Okay. So well, I think I already write down the equation. So we will just move the next one. I hope that I can cover the tutorial part. Okay, so where are we just now? 25. Okay, we're almost done. Oh yeah, this is just to show you that I think I already mentioned that this is your original intercept. When you don't have the dummy equal to 0, which is your beta naught. But then when you have the dummy, you will have another slope, a different slope at a higher level because of the dummy slope. So you have two slope. Okay? Okay, I think you have seen this in the previous chapter. Okay, so let's look at the example. So far so good? Silence means okay. Okay. Okay, because I'm trying to make sure that I can cover some question. So yeah, for clarity. So example, earning differential between men and women. So normally when we talk about earning or salary, in theory, it's stated that men will have a higher earning compared to women. Okay, given that they are at the same level, you cannot compare woman boss and then the normal worker. If let's say their level are the same, they are boss manager. So we are assuming that men manager will have a higher income compared to the woman. Okay, this is by theory, by the textbook. So now, this is your earning, and then you have a dummy. What is the dummy? 1 if the worker is male and 0 otherwise. So 1 because you are assuming that male will have a positive impact on the earning, not the female. That's why 1 is male. If let's say you assume that female has a better income, then 1 is female. This is how you wanna formulate the dummy. Okay, the 0 is something that you don't want to know. Okay, the 1 is something that is your concern, is your interest. Experience. So of course we are assuming that the more your experience, the higher the earning will be on you. And then your error term. Okay, if you hypothesize the men increase their earning more per year of experience. So you are talking about men, and then you are also including their experience of working than women. So you're assuming that men will have higher earning the more they are working. Okay, in this case, you're actually combining the dummy gender and then the quantitative variables of experience. So you can see here, you have the dummy for gender, you have the experience, and then you have the dummy as well as the experience. So this is how it looks like. And of course, this variable is relevant because combinations of these variables, or what we call interaction terms of this variable, have a different impacts on the earning. Sometimes it is even stronger. Okay, the impacts are even stronger. Sometimes the impact for dummy is not significant. The impacts for experience is not significant. But when you have male with a higher experience, so it has a positive impact on earning, and then it turned out to be significant. So the impact sometimes becomes stronger. That's why they have this kind of interactive term. Because if let's say they want to show their impact individually, it may not be significant enough. But if let's say they have a combinations of good characteristics, so the impact can be significant. This is how the economic relationship look like. Okay, and then where am I? What? Okay, so it's here, and then move to the problem with incorrect functional form. Of course, you're gonna have many problems. That's why it's very important to understand the theory, what kind of functional form you have to use. Sometimes a model is logically nonlinear in the variable. So do you care if let's say the variable is nonlinear? Remember, OLS only consider that we have to have linear in coefficient, not linear in variable. Remember, in the previous chapter, we have linear in variable and linear in coefficient. We only consider linear in coefficient. Regardless what happened to the variable, it's okay if let's say the variable is not linear. But the exact form of non-linearity is unclear. In this case, you think that the variable is non-linear, but then you don't know what kind of form. Do you have squared? Do you have quadratic? Do you have into the power of 3 or so on? You are not sure about the non-linearity of the model. Even if theory is not clear, it is wise to avoid choosing a functional form on the basis of fit alone. Because sometimes people think that when your R bar square is high, so it shows that you are able to explain better. So they are adjusting the functional form. When they try the linear form, this is not good. The R bar square is low. And then they just put log, put squared, they kind of adjusting. Remember that you always can somehow manipulate your equation. So it says that if let's say theory doesn't specify what kind of functional form, you cannot simply put the functional form depending on the fitness criteria. This shouldn't be your reference. Okay, so it gives two reasons for not doing this. First, R bar square are difficult to compare if your dependent variable is transformed. Okay, okay, so let me give you the example. So this is equation 1. You have R bar square. So the equation 1, okay, the R bar square is actually 0.52. And this is your equation. Y equals to beta naught plus beta 1x. And then plus, let me just give you one variable, error term, epsilon. And then this is your equation 2. Your R bar square, you got 0.97. Wow, you think that, well, your model can actually explain 97% of the changes in whatever, in Y, right? So you think that this is good. So this is how your equation look like. You have, maybe you have ln Y equals to beta naught plus, and then you have beta 1. I don't know, maybe you want to put ln as well, x plus epsilon. So basically it says that, no, I want to give different color. It says that although this R bar square, this fitness is actually lower compared to this, but you cannot compare this linear dependent with the non-linear dependent. That's why it says that R bar square are difficult to compare if the dependent variable is transformed. Now you already transform your, where is my cursor? Now you already transform your dependent variable. You cannot compare two different dependent variable. If let's say here your dependent variable is still y, and then you're going to have beta 1 beta naught plus beta 1 x1, and then you have beta 2 x2, and then you have blah 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 blah, and turn out to be your R bar square is maybe 0.79. So in this case, because your y is the same, okay, the level is the same, it is lin. So you can say from here, well, this is better compared to this because your dependent are the same, but you cannot compare with different independent variable. Never do that. It is not correct. You are comparing given different level, different stage. Okay, so an incorrect functional form may provide a reasonable fit. Sometimes it is incorrect functional form, but remember you are talking about data. They may mistakenly give you a reasonable fit within the sample, but have the potential to make large error or forecast error when you estimate outside the range of sample. Okay, remember last time, I think this is slide number 7. Where is it? This one. Okay, this is the example that we cannot rely on the constant term. Why? It says that as the constant term is an estimate of y, when r square is your independent variable, are estimated outside the range of the sample observation. So normally your estimation is what we call is weak. Okay, so you tend to estimate outside the range of sample, outside the observation. Okay, so where is it just now? Okay, so basically, even though it says that, even though you have a reasonable fit, your R bar square is nice, but then you have incorrect functional form, basically you are making large error, because normally you are estimating the observation outside the range of sample. Okay, so it says that the main point is that even though your theory is not clear, you are not sure, don't simply put the functional form referring based on the fitness of the model using the R bar square. Don't. So you only use the different functional form if, let's say, it is supported by the theory. Okay. So next, it says that this is the same point, but then I just want to show the example. R bar square cannot be used to compare model, as I have written here, where the dependent variable has been transformed from linear to different version, right? Remember, you cannot compare different dependent variable, different functions of dependent variable. Suppose. So I already explained this point, but I want to show the example. Suppose you were trying to compare a linear equation with semi-log. You cannot. So the first one is linear, the second one is ln-log. The second one is log-ln. So it says that you cannot do that because the total sum of square of the dependent variable is not the same. If you want to compare, you have to make sure that the total sum of square in the dependent should be the same. Okay, so in that case, you can compare between the two equations. At the moment, their total sum of square are not the same. You cannot compare these two different cases. Okay. In general, I think I already mentioned about extrapolation and interpolation. Extrapolation means, do you still remember what is extrapolation? Should I explain what is it or should I skip it?
Explain, madam. Explain.
Okay, so there are two concepts. One is intrapolate. Another one is extrapolate. We can say interpolation, extrapolation. So interpolate means that you are estimating your equation based on the current observation. For example, you have this is x1 and then you have x2 until x5. This is your current observation. So when something is missing, for example, your observation is missing, so you will take just these 5 values because at the moment this is your sample. This is the value of your sample. But extrapolation, when you estimate something, remember your variable is your value is just x1 until x5. But extrapolation means that when you estimate your model, you are taking a different value which is not even within your range. So you may consider, okay, x1 and then x2, and then you have you think that, well, perhaps x3 and x5, x4 are the same. I want to consider x6, x10. So x6. So x6 and x10 are not even in the range of your observation, but you want to include it. Why? So normally, to be safe, people will use interpolate because when you are using the existing value, the same sample that you have, so your error will be small. But when you use extrapolate, because you are taking the value which not even within your range, so the error could be large. So this is the case that sometimes, remember, economics are unpredictable. You never know. Sometimes you're going to have external shock. External shocks means something that you haven't predicted. For example, COVID. You haven't predicted that you will face this issue. So in the case of COVID, people will use extrapolate because this is never been in your range, never been in your estimation, but suddenly it's come and it changed everything in the market. So they will use extrapolate technique. Okay, so this is about the concept. So let me see, what is it? In general, extrapolations of a regression. In extrapolation is actually estimations of your regression using the value outside the range. Extrapolations of a regression equation to data, okay, to data outside the range, okay, as I mentioned to you, over which the equation was estimated. Oh well, this is just the textbook words. So they are saying that if you do the extrapolation, you estimate the value outside your range, you're gonna have a large forecasting error because we are estimating, we are doing the forecasting. So the error will be large, and you're gonna have incorrect conclusion about the population characteristic or value, because you are taking value outside your range. This risk is heightened, means that it's even worse if the regression use incorrect functional form. Okay, if the functional form is correct, so the error will be smaller, but the error will be large if, let's say, you have this incorrect functional form. So let's see how does it look like. Okay, I just want to tell you that you shouldn't use incorrect functional form, or else you will make more error, double error. Okay, so this is correct functional form. So you can see that this is your sample. If you can see my cursor, this is your sample, this is your observation. But then, using the correct functional form, you are estimating here. This is out of sample. You are estimating here. So this is the extra here. The sample is just from here. So the extra here is out of your sample. So you are saying this, you are estimating this. So basically, the error is less, because if you can see your sample, the observation is actually decreasing, right? So you can see that your observation is decreasing. And if you can see the out of sample, even though it is outside the sample, you are estimating something outside, but then the value is still decreasing. So even though you may make an error, but the error are still following the same trend, decreasing. But what happened if, let's say, you're using different functional form? So your functional form, you're using quadratic. It shouldn't be quadratic, right? But you're using quadratic. So this is your sample. If you can see my cursor, your sample is around here, but you are estimating outside the sample. So if you can see that, well, means that the error is actually bigger. So it doesn't really, if you can see here, perhaps, well, basically the true line is actually, the true form is actually quadratic, but you are not estimating quadratic. So you can see that in this case, your observation is going from up, down, and then it's increased, right? So you're going to have a quadratic form. But now, when you estimate outside it, so what happened is that you don't know, is it linear? Is it you don't even know what kind of trend it is, this sample. Okay, so it says that if you are using different functional form, your error will be larger. But if, let's say, your functional form is correct, you may have an error, but error is not that large. Okay, so next, well, the same thing in this case. You can see, well, the same, this is semi-log function. Semi-log function, you will see that your sample is like increasing at the decreasing rate. But when you estimate outside the sample, it is still increasing at the decreasing rate. So you have the same pattern. If you're talking about this one, the linear, okay, you can see that linear is like you have a straight forward, okay, straight line. So linear, you have like negative shape. So your what you call, your sample should be falling. But then, because you estimate outside the sample, as if like it has a positive line. Okay, but in total, in general, it just want to tell you, you may make error, but with the incorrect functional form, your error will be larger, maybe even more. That's it. Any question? Any? Oh, I didn't expect that it will take some times. Okay.
So on Wednesday we have quiz, right?
Yes. So can we have a quick look on the exercise? Okay. So your quiz will cover chapter 6 and 7, only 2 chapters. Okay. Let me see which questions are more important. Okay. So luckily, when I use my laptop, I can just type the page number. But in the desktop, at our class, I cannot really type the number. So let me see. Question 2, page 178. 178. Is this better to explain or another one? Let me see. How about 180? 180, question 4. I think for question 2, you can understand it by looking at the answer. Let's explain question 4. Okay. Okay, this is chapter 6. Remember, chapter 6 is about, oh, I put it here because I want to refer to this. Chapter 6 is about specification, but the variable that you want to put in the equation, right? Okay. So, what is the question? For each of the following situation, determine the sign. And if possible, comment on the likely size of the expected bias. Whether you have a positive bias, negative bias, or no bias at all. Introduced by the omitted variable. Remember, chapter 6 is about relevant variable. Whether you have put relevant or irrelevant variable, or omitted variable. Okay. Now, your task is to determine the sign and what kind of bias it has introduced because of the omitted variable. Is it negative bias, positive, or no bias at all? In an equation for the demand for peanut butter. Okay, the impacts of coefficients of, okay, I think, I don't know, should I write the equation? Paint painting. Okay, so it says that this is the demand for peanut butter. So beta naught plus beta 1. So what is the beta 1? The impacts of coefficients of, you have disposable income. Okay, and then you didn't put one more variable, and then you have epsilon. So basically, you have to have what we call this variable. What is it? You have to include the price of the peanut butter. Okay, this is the price of peanut. But you didn't include in the demand for the peanuts. Of course, the price will have an impact on the demands, right? Higher the price, maybe lower your demand for peanut because it's expensive. But you omit this. Okay, you omit this. So what happened? What happened, do you think, to the coefficients of your disposable income? So let's look at your disposable income. So disposable income, what is the sign? What is the hypothesis sign for disposable income on the demand? Is it positive or negative?
Positive.
Positive, because you are assuming that higher the income, higher your demand for peanuts. Okay. Well, if you're talking about chapter 7, what kind of functional form here? If you still remember.
This is a linear.
No, when you talk about
Sorry,
income, it is
this is
increase. Remember, when you talk about your consumption, you increase at a decreasing rate. Remember last time? When you eating one plate of rice, you are happy. Your utility is increased. But the more you keep eating, your utility is high, but increased at a decreasing rate. So you're gonna have loan income and unit for demand. It's fine. This is just to tell you how to relate with the chapter 7. Okay, so your disposable income is positive because higher the income, higher the demand for peanuts. How about the sign for your omitted variable, the price? What is this the sign for the price? Positive, negative?
Negative.
Negative. So higher the price, lower the demand. So now you have positive and negative. So most likely your bias will be negative. This is how you look at it. Okay? So let's look at the second example. In an earning equations for worker, this is earning. So earning will be here. I want to use a different color. Black. This is earning. Beta naught plus beta 1. What is your beta 1? The impacts of coefficients of experience of omit. Oh, so you want to know the impacts of experience when you omit. What did you omit just now? You omit age. So you omit age. So now, what is the signs of experience?
Positive.
Positive. You're assuming that when you have higher experience, higher earning. What is the signs of omitting the age? What is the signs of age?
Also maybe positive.
Yes. So let's assume that you don't know that H has a squared function. Let's assume that you don't know H because this is chapter 4, right? And chapter 6. You haven't learned about the functional form. So H, you assume that higher the age, the more the age, the elder they are, the higher the experience compared to those who are fresh graduate. So you are assuming that the H is also positive. So basically, you are introducing positive bias. This is negative bias. Okay. So can you also answer for the next question? Is it clear to you how you want to solve this question? So far so good?
Sorry, madam. For the first one, so if we have positive and negative, it will be
Negative.
negative bias.
Yes.
But if negative negative also leads to negative bias.
And negative
So,
negative, is it negative?
no, if we found out negative and negative, so it will be negative bias.
This is like mathematical equation. When negative meet with negative, will you have negative as well?
I see. Okay. So, okay. That's where
Okay.
I confused madam. Also,
Okay,
if
it's
we have
okay. It's
negative
okay.
and negative, it will have the result of positive bias.
Yes, that's right.
Okay. Okay.
Okay. Thank you for
Okay.
asking. And the last one, I hope that you are clear with this. But the last one, just to tell you, it has no bias in an equation for daily attendance of outdoor concert. Okay, this is your attendance on the concert. The impacts of coefficients on weekend. So this is coefficients of weekend. Of omitting variable that measure the probability of precipitation. Precipitation is raining. So, what do you think? What do you think? Can you? I need more. Okay, can I? Can I just write here? So, what do you think? So, this is actually where is my cursor? Okay, this is your attendance of concert. Attendance. So it's a functions of you have beta 1, beta naught, and then you have beta 1, which is weekend. So somehow during the weekend, so weekend is just like the dummy variable. Okay, 1 is weekend, means that they are conducting the concert during the weekend. And 0 otherwise, they don't conduct this is 1 weekend. And then you are omitting, what did you omit here? You are omitting, where is it? Precipitation, probability of raining. So you omit raining. So you believe that when the probability of raining is high, what happened to your attendance? Maybe your attendance will be
No.
Low.
no attendance. So what is the sign?
Negative.
Negative.
Okay, negative. But how about weekend?
Positive.
Do you think that the concert will be conducted on weekend? Not necessarily, right? I mean, do you think that
Mostly.
mostly?
Yeah.
Yes,
Mm.
concert can be affected because concert will be joined by those who are younger. So they are free on weekend. On the weekdays they are working.
Mm. So what is your expected sign here?
Positive.
Positive, yes.
Positive.
Yes.
Okay. So if you have positive here and raining negative, so maybe you want to have negative, right? Positive and negative. But somehow in the textbook, um, well, the weekend and raining has no relationship. Just because it is during the weekend, you will have the raining. So basically, weekends and probability of raining has no relationship at all. Okay, how come you gonna say that raining will affect weekend or weekend will affect raining? So in this case, you don't have any bias. The bias is 0. So if you omit the raining, even though raining is important variable affecting your attendance to the concert, but raining will not affect the weekend. They are independent variable. Can you see that? Do you think that because it is raining, it is omitted, then it will affect the weekend? No, it will not affect the weekend. It has nothing to do with the weekend. Okay? So this is just the examples of zero bias. You introduce bias, but the bias on the weekend is zero because weekend and raining is not related at all. So this is one example for question 4. I think that comparing question 4 and 2, 4 needs some explanation. 2 you can just read by yourself. Let me just go to chapter 7. Let me see between these two questions. Page 210 or page 211? Page, let me see what happened. 210 and 210, question number 2, right? 210. What is the question here? Oh, yeah, 210. 210 is good. Okay. And then 211. Let me see 211. Number 4. Well, this is also good. Okay, let's see. But yeah, let me see the reasoning part of it. 210. Okay, so what is it here? Painting. Okay, so for each of the following pairs of dependent and independent variable, pick the functional form. Remember, we just learned about functional form. So that's why I think this question might be interesting to be discussed. Pick the functional form that you think is likely to be the appropriate. And then remember, if you selected incorrect functional form, you are making more error. Then explain your reasoning. Okay, now sales of shoes is a function of disposable income. I think I already mentioned this, right, just now? Okay, sales. So normally you're gonna put Y, but it's okay. Let me put just sale. Sale is a function of, this is beta naught plus beta 1. You have disposable income. I did mention about this. So what is it? So when you talk about income, disposable income, and the sale, what was
Linlock.
Linlock? Can you explain the relationship?
Because it will increase at a decreasing rate. Is it?
Explain. So when your disposable income increase, so you are saying that this is linear, and this is log, right? So
Yes.
if let's say, let me give different color. If let's say your income increase at the increasing rate, your income increase, so your sale will increase at the what a decreasing rate. Everyone agree with this?
I don't know, madam. I'm confused already.
Anyone? So when you talk about, this is sales, right? Sales is actually from the perspective of the producer. So when you know that people's incomes are increasing, don't you think that you have to augment, you have to sell more? Don't
Yes.
you think so? So just now we are talking about the income, and then our dependent is actually something to do with consumption, right? So consumption is from your utility. When your income is increased at the increasing rate, but your consumption will increase but at the decreasing. Okay, you are increasing your income, but then consumption will increase but at the decreasing rate. But for this income and sale, when your income is increased, people will, the producer will augment, will increase it. So this is like increase at the increasing rate. Can you see that? For the consumption, because your utility will fall. Even though you are happy, you increase your utility, but your utility increase at the decreasing because your utility have a diminishing power. But for the sales, people want to sell more given your income. Okay? Okay, so some study, well, depends. Some people, so normally what happen is that in this case, you can have increase in unit, but cell will increase more. Okay, so you can also have that. You can also have, when we talk about income, you can also have increase in income large. You can also have increase in cell even large. So you can have, so let me give you another color. So you're not using this linear. You can have, what is it? Increase at the increasing rate. So you can have, this is linear. This is a normal increase, but then the cell will respond more. So this is log. You can have log lin. You can have this functional form. You can also have log log. Means that when people incomes increase more, the cell even more. So you're gonna also have elasticity. Well, okay, elasticity given that, yep. Yeah, you can also have elasticity. So normally you're gonna have this first function. You have a small increase, but then the producer will respond with more increase. That's why you have the log. You have the log. You can also have log log. You can also have this. Okay. So you can have two form, even though the textbook only give you just one form. Okay. So how about number B? Attendance at the Hollywood Bowl Outdoor Symphony. So attendance at the symphony concert on a given night. So this is just your attendance. It's a function of whether the orchestra's most famous conductor. So this is like your attendance depends on the famous conductor. Do you think that if, let's say, it is the famous singer or conductor, your attendance will be higher? For example, we are talking about the concert conducted by Siti Nurhaliza. If, let's say, it is the famous actor, famous singer, your attendance will be more compared to the just a normal person. What do you think?
Agree, madam.
Agree. So
Yes.
what will be the form? What will be the functional form? So in this case, let me just write it down here. Attendance on concert is a function of beta naught plus beta 1. This is a dummy variable, right? Whether the orchestra's famous actor or not. So this is a dummy. What is the functional form? Anyone? So when we talk about a dummy variable, it's always linear. Lin. You cannot have any functional form for dummy variable. Normally for the dummy, one unit, not really one unit. Remember how you want to interpret the dummy? It is always in the linear form. So when you have the dummy, normally the dependent is also linear. Unless you have other variables which may change the functional form of your dependent. But if, let's say, you only have dummy, it will be linear. So far so good?
Yes, madam.
Okay, you want to proceed or we can just stop here?
Proceed.
Proceed. Okay. Okay. Because I think that this question is very important. It will tell you what kind of functional form you have to choose depending on the variable, right? Okay, C. Aggregate consumptions of goods and services. And then aggregate disposable income. Okay. So this is consumption and disposable income. I think you know, right?
Link log.
Yes, that's right. But sometimes when we talk about, normally this is the form, but when we talk about aggregate, it's a large amount. Some people want to put log. Because when you talk about the macro variable, you are dealing with a very large number. So when you have log, it will somehow reduce the volume. It will make the number of your, the coefficient will become smaller, easy for you to interpret. So it is supposed to be in log. It can also have log. Number D, the money supply in US, and the interest rate. So this is the supply of money. It's a function of Better one is interest rate. So what do you think? Higher the interest rate will be, what happened to the money supply? What happened? Will you supply more?
No.
No.
Yes.
Yes? No? I have to check the relationship between these two variables because this is a macroeconomic, so I don't remember the relationship, but in this case we are talking about the functional form, right? So when you talk about interest rate, normally you are using log. For the interest, it is normally when you want to explain interest rate, you are using percentage. Percentage is a log. Okay, so you can have log form here. How about the money supply? Money supply can also be log. It can also be in terms of unit. Units or log. Depends. Okay, both are okay. Okay. So the last one, average production cost. This is the cost and the number of box produced. I think we just learned about production cost, right? Let me write it here. This is a production cost, and then it's the functions of number of box or number of output, number of box.
So it's polynomial, is it, madam?
Production and the number of, yeah, you can have quadratic here. But then how does it look like? I mean, is it linear? It's not linear, right? So how does it look like? Should we put semi-log? Should we put what? Log? How we want to put it? Anyone? It is polynomial, but how we want to put the functional form? Normally, for the production cost, it is linear, lin. But then, sometimes the cost will be, let me see, if you have something like this, this is decreasing, this is increasing at the increasing, yeah. Normally, it should be lin, but you can also have decreasing at the decreasing rate, increasing at the increasing. For the cost, will you have that if, yeah, you can also have production cost that decrease at the decreasing rate. Yeah, it's possible. So you can have ln is here. You can have log lin or lin. Normally it is lin, but you can also have log lin. Okay, so the textbook will just give you one answer, but you can also have another forms of functional form, another form, a different form. Okay, so both are accepted if, let's say, you are able to explain the relationship. Okay, so far so good.
Good.
Okay, so we have covered this. I think the other question is even easier to explain. Just to refer to the answer. So, any other question before we end our class? Let me try to stop sharing. No, not stop presenting. Is it stop presenting? How to stop recording?
There, madam, manage recording that.
Stop recording.